Hello students, welcome back to my channel Science for You. So the last time we were doing the topic motion. Today we are gonna continue the same topic, but before we continue, last time we have learned about four topics. The first was we have learned what was distance, then we have learned what was displacement, then we have learned about speed, and last of all, we have learned about velocity. So, first of all, let us quickly revise the topic speed because it is further needed in this video. So, we need to know what we talked about speed. So, what speed basically represented was total distance traveled divided by total time taken, right? So what does speed represent is a speed means that it is tells us the total distance traveled divided by total time taken. In basically what speed was trying to tell us was like how much distance is traveled per unit time. So on the basis of speed, right? Motion can be divided into two types. Which two types? First is called uniform motion, and the second is called non-uniform motion, right? Now, I have said there are two types of motions on the basis of speed. First is uniform motion, second is non-uniform motion. So we will learn about both types of motion one by one. So very first motion we are going to learn about is uniform motion, right? Uniform motion. Here, like I have typed a definition. What definition is? Uniform motion means an object travels equal distances in equal intervals of time. So here you have to keep in mind what I have said is equal distance in equal time intervals. Time intervals. To get it better, let us take the example of a car, right? So here we have a car. Mm, so what happened is like I note down or observe the readings of a car that how much distance has been traveled by the car in every minute, so like in every hour. So what I have noticed is car traveled 50 kilometer in first hour, then it again traveled 50 kilometer in second hour, 50 kilometer again in third hour. So what here is happening is that in every 1 hour the car is traveling a distance of 50 kilometer. Such a motion is called a uniform motion, or in other words, if you say like if you can also see over here that for the first hour, like it traveled 50 kilometer in a time period of 1 hour, right? So the speed here is 50, right? Then again it 50 kilometer per hour was the speed. In second hour means the again the time period is 1 hour and the distance traveled is 50, so the speed again turns out to be 50 kilometer per hour. And for third also the speed turns out to be 50 kilometer. So here you see that the speed is not changing with time. It is always like same 50 50 50. At any time if I will look at the like meter readings of the car where like you see the speed of the car, it will always show 50 kilometer per hour. Such a speed is called as constant speed. So a type of motion, okay? So uniform motion can also be described as a kind of motion where the body travels with a constant speed. So we have learned about two types of definitions of uniform motion. The first definition, which says that a motion is said to be uniform if the object travels equal distance in equal intervals of time. Or the second definition, an object is said to be in uniform motion if it has a constant speed. Okay, now I hope you have understood uniform motion. Now let us move on to our next um, next topic, that is non-uniform motion. Now, non-uniform motion means an object travels equal distance in different intervals of time, right? So here let us again take an example of a car. What happens is, like if I notice like how distance is changing, so for what will happen is, like for first, like I said, equal distance in different intervals of time, right? So for first hour, for first hour it will travel 50 kilometer, then it will travel 50 kilometer in 30 minutes, right? Then it will travel 50 kilometer in, I'll say, maybe 2 hour. Then it will travel 50 kilometer in what we say, suppose, what, let me say, 45 minutes, right? So here what we are saying, that they are traveling equal distance but in different intervals of time. Like, to travel the same amount of distance, the time taken is different, or I can say the speed is different. Speed is not constant, right? Or we can also say in other words, like for example, if I notice the car and like notice the speed of a distance traveled by car in every hour, so what you will observe is, like, it travel 50 kilometer in first hour, 80 kilometer in second hour, 90 kilometer in third hour. So, what here is happening is that you can say that equal distance in different intervals of time, or you can also say that different distances in same intervals or in equal intervals of time. Equal intervals of time, or you can say the speed is not constant. Now you have taken account over all the definitions that one thing is different or varying, like either the speed keeps on, sorry, either the distance keeps on varying or the time keeps on varying. If the distance is equal, then the time intervals will be different. But if the distance is same, then if the distance is same, then time intervals will be different. But if the distance is different, then the time interval will be same. That this is there is a discontinuity, right? Now after that, let us move on to our next topic, that is acceleration. Like, it is also a definition. In the same way we have learned about what is distance, displacement, speed, velocity, let us move to the next definition we are gonna learn is acceleration. What here I have written is the definition, but before you read the definition, let me take the take an example, right? Um, okay, let us take the example of the car itself, right? So the car is moving, right? Like, in we have studied the non-uniform motion. What was happening was, for first time its speed was like 50 kilometer per hour for the first hour. Then it went on to 80 kilometer per hour for the second hour. Then it went on to 90 kilometer per hour. Now, Now, what is happening when the speed goes from 50 to 80 kilometer per hour? There is a change in the, like, here I'm talking about, like, let me not talk about speed, let me talk about velocity. Like, let me talk in the terms of velocity, right? So When I talk about velocity, there is a change in velocity. It is increasing, like it goes from 50 to 80, then this velocity is changing from 80 to 90, right? So I am when the velocity is changing, this change in velocity, change in velocity refers to what is a topic? Acceleration. So what is acceleration? Acceleration is the change in velocity over time, and here is a definition. Acceleration is the rate at which an object's velocity changes over time. So how we will write the change in velocity over time and acceleration? So what acceleration is basically change in velocity on time. Then how it is written is v minus u by t, right? So what is v? V is your final velocity minus u is your initial velocity, right? It is time taken. Wait, let me change the page and explain again. So we were on the topic acceleration, right? So what I am trying to say, acceleration, first of all, keep in mind it is represented by small a. What acceleration means is, like in mathematically how it is represent, it is final velocity minus initial velocity divided by time taken, which can be written by v minus u by. So, for example, I take the same case what I was taking of the car, right? Like same. Okay, I have been drawing car way too much, right? But let's take it. So first the speed was 50, and then speed changed to 80, right? So here the first speed was 50 kilometer per hour, right? So and the second is 80. So final velocity was my 80 and initial was 50. So it will be 80 minus 50, and how much time it was in first and second hour. So the total time taken to change was 1 hour, right? So the acceleration comes out to be 80 minus 50. 30 divided by 1 is just 30 kilometer per hour square. Now keep in mind the units of acceleration. The SI units of acceleration is meter per second square. Okay, it is meter per second square. I hope you have gotten this topic. Like what we have done till now is acceleration and deceleration. Oh, sorry, motion, uniform motion, non-uniform motion. Now let me talk about a term called deceleration. What does deceleration means? When suppose, for example, let me take the example of car. If the car goes from speed like velocity of 50 kilometer per hour to a velocity of 40 kilometer per hour, then in a time period of, let us say, 1 hour, then what has happened is the speed of like the velocity of the car hasn't increased, it has decreased. So here it is not acceleration, here we call it deceleration. That when there is a decrease in the velocity of the body, then we say it is deceleration. We will say like acceleration, the formula for deceleration is same as that of the acceleration, but like the value comes out to be same. We will say that there is a deceleration of n, right? Okay, I hope you have got this topic. Now we will move on to the other topic, and which is like After that, like it won't, I won't say it's a topic. It is basically, I'll show you the graphical representation. Graphical representation of linear motion, right? So we are gonna talk about two types of graph. First is gonna be a distance time graph. Second is gonna be a velocity time graph. Okay. So we are going to talk about graphical representation, but we are going to talk about two types of graphs. First is distance time graph. Second is velocity time graph. So let me go to and add some more slides as it is required. So first of all, let me draw a graph, right? So here is so this is a okay. So here it is like this. First we are talking about distance time graph. Distance time graph, right? So what will happen in distance time graph? This will represent your time, like x-axis will represent your x-axis will represent your time, and y-axis will represent your distance. This is distance. Let me write it as this. This is my distance, right? You have like say distance is in meters, time is in seconds. Now, if I'll talk about like different types of graphs, so basically what we are going to do is like we are going to plot like a graph of distance and time. For example, like if I have taken a car and the distance is somewhat like this. This is the distance, this is the time. So let me represent it by as distance time for like it 10 or like 10 meter in 1 second, 20 meter in second, 30 meter in third second, 40 meter in 4 seconds. So if I draw, so it was like 1 second and it has 10 point is here. Second, the distance traveled was 20. So point is over here, third, fourth, 30, 40, right? Sir, look carefully. The graph here will be like so. Let me change the color. Wait, let me erase. The line is wait. If you see carefully over here, right? What you will notice that yeah. Wait. Okay, let me draw a line itself, right? So how to draw? Draw with ruler. Let me let me do it. Wait, no, it's not working out. So let me show it. Like if I draw it, so it's happening like there is not. So that's it. That's it. Fine. Finally. Like, so if you look carefully, so this is how you are getting your graph. So the graph is a straight line. But if you notice carefully over here that it is a graph of a uniform motion, right? Like uniform motion. Like for like it has traveled 10 meters in first second, then again it has traveled 10, then again it has traveled 10 meter, then again it has traveled 10 meters. So it is the graph of a uniform motion. So we what we have learned is that the graph for uniform motion line will be somewhat like a straight line. Okay, now after that, if I similarly if I draw a graph of a non-uniform motion, non-uniform motion, right? So it will come out to be like this, like a case in which the time, distance in meters over there. So it will come out to be somewhat like this. Okay, it is a case in which the car is not like deaccelerating, or the speed is not decreasing at any point, it is only increasing. So you will notice that there is curve over here, right? Curve, there is a change, regularity, sorry, irregularity over here. Okay, got it. Sorry, not, you won't say irregularity, but basically you will say like it is not a straight line, it is rather a curve is being formed, right? Now this is the example of a non-linear. Now what is important, you need to know what does this graph helps us to know. Like for example, let me take again uh, this let me take this graph only for a uniform motion, right? Distance, time in seconds, right? So where we need to calculate the slope. What is slope? I don't know if you have done it or not. What is slope? Slope is basically uh, y2 minus y1 divided by x2 minus x1, right? Means y2 coordinates, for example, if it's the time is t1, t2, and the distance is s2 and s1. So what slope here is going to be like x2 my sorry s2 s2 minus s1 divided by t2 minus t1. Here, what slope is giving? Change in distance, right? Take a change in distance divided by change in time. So what slope of a distance time graph tells us? It tells us the speed of the object. What is it telling? Slope gives us the speed of the object. So if I have given you a graph like this, right? So if I take this example only for this and this, if you notice carefully, so if I calculate the slope, right? So y2 y2 is 30 minus 20 divided by t minus 2. This gives us 10 by 1. So this is 10 meter per second is the speed. You can see very clearly what the slope tells us. Slope tells us the speed. So you have to keep in mind that the in distance time graph, slope is slope tells us the speed of the object, right? You know, like may it be uniform or non-uniform, like slope is gonna tell us the speed of the object at that particular period of time, right? Now, okay, so I guess the video is being way too long, but I need to, okay, as I guess the video is going to be way too long if I continue. So let's just end this video over here. Um, I hope you all have understood whatever I have taught you till now. Whatever I have taught you till now, and I hope you have all liked the video and understood the concept. Whatever we have done uniform, non-uniform motion, we have done acceleration, and we have done distance time graph, and that's it for the video. We will continue further the graphical representation in the next video. Thank you so much for watching. Thank you so much for watching. Bye bye.